Hey guys, welcome back. Today we're going to talk about compound interest and something very special about this problem. Here we have Jason invested $2,800 in an account paying an interest rate of 2.7%, compounded continuously. How long would it take to grow to be 3560? A couple things in here that we need to keywords that we need to take special note of. One, this says continuously. Continuously tells us we're actually going to use a very special formula, and that formula is A equals P to the E times E to the RT. This E represents continuous compounding. This is not found in the other formula. This is why it's very unique to this problem. When we talk about continuous compounding, always remember we need to use a formula with the E in it. So continuing to read our problem, we have here Jason invested $2,800. This is a key piece. This is his investment, okay, in an account paying an interest rate of 2.7%, compounded continuously. How long would it take to grow to be 350 or 3560? Okay, so we have, let's see here, our A, this is our amount here. Okay, the 2,800 is going to, oh no, I apologize. That is incorrect. That becomes the 2,800, Jason invested $2,800. This is the principal amount that he invested. The interest rate is 2.7%. That is our little R up there. Compounded continuously, we know that that's already E, right? Continuously, that's our E. And then, of course, then we have how long would it take to grow to 3560? And the 3560 is the amount, the future amount, okay? So when we put all of these pieces into our formula, what is it? Oh, and one other piece, we have how long would it take? T, this is what we're trying to find. That's T, okay? Additionally, what we want to do is we want to convert, when we deal with interest rates, we don't generally we talk about them in terms of percentages, but we actually apply their values as decimals. So this 2.7% actually comes when I move the decimal place 2 places to the left, 1, 2, I have a 0.027. That is the decimal that we'll be working with today. Okay. So I'm going to put all of these pieces into our formula, where A is 3560, and this is equal to 2,800, our principal, times our continuous compounding constant, times R, which is 0.027, and our time T, okay? So the way to solve this, since what we're trying to find is how long, and that's T, this is up in the exponent. So I have to ferret away how to get it out of the exponent to solve for it, right? A couple of things I have to do first. I kind of want to clean this up a little bit, make it a little bit easier. So what I'm going to do is I'm actually going to divide both sides by 2,800. Okay, what do I do to one side? I do the other. I keep it balanced. I do that, and the coefficient of E actually becomes 1. That's the reason why we did it. So the left side just becomes, oh, I apologize about that. Let's fix that real quick. We have 3560 divided by 2,800 is equal to E time raised to the 0.027 T. Okay. I'm actually also going to reduce my left side by 10. I'm going to divide the numerator and the denominator by 10, what that will do is that will eliminate the 0 at on the very last of them, the first place digit, the ones place. Okay, now here's what I have. I have the 356 divided by 280 is equal to E with the 0.027t raised to the 0.027t. But I still need to find t. So I have two things. One, I have this power rule. I don't know if you guys remember. It's called a power rule. And it says that I can actually bring this down here. But power rules only apply to logs and natural logs. So I have to figure out, okay, I'm going to have to take the log or the natural log of both sides. And how do I decide whether it's a log or natural log? Because we got two of them, and I'm completely confused on how and where to use them. So here, one of the key pieces here, this is E right here. And E and natural log of E has they're kind of special. They're a special pair. So if I see that there's an E usually in the problem, and I have to find a value that's in the exponent, I'm more than likely going to take the natural log of both sides. So you can kind of pair those two together. If E is here, I'm going to take the natural log of both sides. Okay. So I'll take the natural log of 356 over 280. Oh. Let's make that the same color as my other parenthetical, is equal to the natural log, okay, of E to the 0.027t. Okay, so now that I've taken the natural log of both sides, only now can I apply the power rule. So now can I bring this to 0.27 or the exponent down in front? So by use of the power rule, I will do that. So now I'm just going to rewrite the left side. We have the natural log of 356 over 280 is equal to 0.027t times the natural log of E. And this is done by the power rule. Okay. Now, remember my telling you that the natural log and E are a very special pair? Well, they do. So we know that but the natural log of E actually reduces down to 1. Very special. You can kind of think of them as reciprocals. One does or undoes what the other does, okay? When they're paired just like that, okay? So now what we have here is we have the natural log of 356 over 280 is equal to 0.027t. But my problem is asking for how long would it take to grow for this. I want t years. I want one whole t. I don't want some fraction part of t. See right now I have 27 thousandths of a t, and I don't want that. I want one whole t. So what I'm going to do is I'm going to divide both sides by 0.027. Okay. Doing that, what it does is this reduces to 1, which is exactly what we wanted. We did that with purpose, and we were very intentional about that. So my left side of my equation looks like this. We have the natural log of 356 over 280 divided by 0.027 is equal to t. Well, that's great, but what value is that? So yeah, we found t, great. However, so how long would it take? Typically, time is measured in years, and this looks like a very odd way of representing years, doesn't it? So we're going to actually plug this into our calculator and see what the calculator tells us, as long as we entered it into the calculator correctly. Okay, so we have the natural log of 356. No, that didn't work out. We have the natural log of 356 over 280, right? And then we're going to divide that by 0.027. All right, so t is approximately equal to, okay, 8.894, dot, 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 dot means the number goes on infinitely. So we have 8.894 continuously. And since time is represented in years, we know that that's some value represented in years. Now, depending on how the question is phrased, ours did not specifically ask round to the nearest year or the nearest tenth of a year. But if you are asked to round to the nearest tenth of a year, what we're going to do is we're going to take, since this here is a tenths place, we look at the hundredths place and go, okay, what do we do if it's 5 or more, right? We round up. If it's 4 or less, we leave it alone. So here, if we rounded to the nearest tenth of a year, be 8.9 years, okay? If the question asks us to round to the nearest year, again, this would be anything on the left side would be the whole year. So we look at one place to the right, and 5 or more, we round up. 4 or less, we leave it alone. So this particular case, it would be 9 years if they asked us to the nearest year. I think one very important piece that we also need to do is show you is that you should check your work. Let's just delete this. Okay. So if we are asked, we always plug back into the original problem. Okay. So we're going to use this one right here when we plug it back into the original problem. So what do we have? We know that A is what we're trying to find. We want to make sure that our time gives us this, okay? So what we're going to do is we're going to plug this into our calculator. So we have here our principal, 2800 times E raised to the 0.027, okay, times 8.9 years. So 8.9 years gives us our 3560, which is actually really is pretty close to this, okay? If by chance it asked us to raise it to the nearest whole year, to the nearest year, we have 2800 times E to 0.027. Okay, let's do it. Okay, raised to the 0.027. Okay, times 9. So you can see here that if it's raised to the nearest year, we actually make $10 more than we do if we keep it down to the, we can see here that if we wanted the 3.5, or if we wanted to see the number of years that would actually grow as closest to 3560 as possible, that would be 8.9 years. If we use the nearest year, which would be 9, we would actually grow a little bit more. So the longer we keep our money in an account, the more it will grow at the end of the day. And that's what that means. All right, well, I do hope that you found this video helpful. If you have any questions, please feel free to reach out. If you have anything that you want me to go over, reach out as well, and I will do my best to put something together and get it back to you. Thank you so much, and have a wonderful day.